So hello everyone. Let me come to the second question of this DSA series, which is buy and sell. Best time to buy and sell stock. You can solve it using greedy approach as well as dynamic programming approach. Now, what it is given here is that you are being given an array, say price array. Now, each and every element is the stock price of that particular day. Suppose for indices I, the stock price is at 7 rupees. For the second index, that means for the second day it is 1 rupee, etc. So you have to find the maximum profit by buying it on one day and then selling it on another day. Okay, so these will be two different days. So different days means the different indices. So we have to buy on one day and we have to sell on some different day. Okay, and it is a pretty logical thing that we cannot sell before buying. Okay, after buying only we can sell it. So the profit is also always sell minus buy. Now let me declare another variable, say answer, which will store the final answer. Now let us initialize this buy variable. Let us first assume that there is only one element in this array. Okay, so if you assume that there is only one array in this array, then you can buy only at that particular index, right? So buy is 7. Now sell, you initialize it to the second index. Okay, this is 1, because you cannot initialize sell to this index, because buy and sell have to be on different days. Now if I show you the question, here it is given that the prices dot length can vary from 1 to 10 to the power 5. Okay, so if there is a single the length is 1, if the length is 1, then the profit will be 0, because there is no scope of selling that particular product, right? So there will be no profit. So there will be no profit, and so that we can include that as a base case. Now coming to this, now we have to this answer we can max, because we have to find a maximum profit, right? Sell minus buy. Now if we assume that we are selling on this second index and buying on this first index, then what will be the max? Answer is initial profit is 0, and this will be 1 minus 7, which will be minus 6. So it will be 0, because we won't be buying here and selling here, because if we buy in this first index and sell in this second index, then we will be facing a loss. Okay, so that we don't want to do. Now what we can do is, at the same time, if we are facing a loss, then we can, that means the current index, the current element is lesser than the previous buy. So we have to buy at the minimum cost, right? So it will be minimum buy comma the current element. So this will be current element. The current element is array of I. So here buy will become 1. That means we are now assuming that there are two arrays and we are buying at the minimum one. Okay, now while going to this index, the answer will be 5 minus buy. So 5 minus 1 will be 4. So max of 0 comma 4 is 4. So when there are 3, when the length is of 3, then the most optimal answer is 4, because we can buy in this in the second index and sell in this third index. That way we can make a profit of 4. So similarly we can do it until the last index. Here you can see that this is if we sell in this index 6 and buy at this index, then the answer will be 6 minus 1 5, which will give the maximum profit, I think. Yes, here you can see the answer. So so this is how you have to approach the problem. Earlier I have said that you can solve it using greedy. I don't think this is a greedy approach. Uses this is a basic dynamic programming approach. So, but you don't have to declare extra arrays. Okay, you don't have to declare an DP array. You can simply do it in O of one space using these variables, because this is a very easy question. Now, let me go to the code. So we have to see. Okay, let me guys. So if n equal to 1, if the length of array is 1, then the profit will be 0. Okay, now by variable will be initializing it to the first element. Okay, and will be initializing cell variable to the second element. And this is the final answer. So I equal to 0, I less than n, I plus plus will be traversing through the array, and then we will see that okay, if we will update the answer, it will be maximum of answer comma by minus self. Okay, now we have to update the by variable, so it will be minimum of by comma the current element. I think this should work. We don't need to start it from I equal to 0, because we are already initializing by to the first index. Sorry, please tell minus by. Okay. The current element, we are putting the current element to be the cell variable. Okay, because at each index we are trying to get the cell variable. Okay, that means if the current element and minus the previous by element gives the maximum profit, then this particular, we will consider this particular cell price. I think this should work. Okay, this is work. Now if I go into the discuss section, yeah, pretty much the same. I'll be explaining the cadence algorithm in the later part. But this is a variation of the cadence algorithm. It's a very famous algorithm. I think if you are preparing for any interview, you must practice at least some variants of this cadence algorithm, a very important part of dynamic programming. Okay, so thank you everyone. I hope you have understood the code. So here I'm okay. I'm going through the code one line by line. Just wait for a minute. So we are initializing the first element to be the buy variable. That means we are assuming that okay, we are buying at this particular index. We are buying at this in first index, and then after initializing that buy variable, we have while traversing through the array, we will set the sell variable to the current element. That means we will see that if we sell at this particular element, that means if we sell at this current element, what is the profit, and we will then maximize the answer. If the profit is greater, then we'll maximize the answer. But if we find another variable which is lower than the previous buy, that means we won't be buying at that previous buy, we'll be buying at this buy variable. That means this current element. Okay, so this is pretty much the solution. Thank you everyone.